looked at this emulator as, well, this is neat. Maybe I can use it to debug hypervisors because there's not a lot of tools out there to debug hypervisors. And it can help with that. It doesn't really take care of everything, but it gives you some neat capability that you wouldn't have with just software. So, I mean, like I said before, a lot of the things that I've talked about you can do with a kernel debugger. I mean, the macro language and, putting breakpoints in drivers and things. Yeah, you can do a lot of that with WinDebug. But you can't really debug hypervisors so well because even your kernel debugger is still running, at the kernel level, and so a hypervisor is one step below that. And so the ICE is running below hypervisors. So you can do, again, with a few simple macros, you can get a lot of functionality out of that. You still have some issues, like you have to find the hypervisor. I don't really have a good way for that right now. My current way, which I'll show you in a bit, is basically the brute force method of let's just dump a lot of memory and look through it and find the hypervisor. But once you found it, you can set a breakpoint in there and use, again, simple functions to step through it. I've got a function, VMX is enabled, just tells you, hey, is VMX mode on right now? Go to resume is basically, it's like execute to return or something. When you're in the hypervisor, at some point you got to resume the VM, and so this just steps through till you get to the end of your handler. Guest EIP says, well, what is the current instruction pointer of the guest when I'm in the hypervisor? The exit reason, you can get all kinds of useful information from the VMX system. Exit reason says, well, why did I end up in the hypervisor? So these, again, short little series of what are, I'm sure, going to be wonderfully legible videos showing how this works, but I'll tell you what's going on. So actually, in this video, I'm looking at a hypervisor that Sean Embleton put out on rootkit.com a couple of years ago. So it's not a particularly stealthy hypervisor. It's not a virus or anything, but it gives you the idea that we can debug hypervisors. So like I said before, step one is find the hypervisor, and we're just going to brute force it by dumping memory in source point. They have a neat little functionality that is called save program. The idea behind that is that you're going to save the particular process image that you're looking at, but basically you can just give it any range of address space and say save it, which is good because the other way to do it is to write a macro that just goes through and dumps a few bytes at a time, and that's tremendously slower, although this is not great. That's me dumping, I think I told it to dump like 60 megabytes of memory, and it was going to take, 10 minutes or something. It's not the fastest thing ever, but the CPU is halted while you're doing it, so it's stealthy. So once you dump the memory, you have to actually see if you found anything, and for that, use IDA. Open the image up in IDA and start looking for something known. In my case, I'm going to look for OF01C3, which is a VM resume, because again, if you're in a hypervisor handler, at some point, got to get back to the guest. And so open it up, search for that. I'm going to find it. So once you've actually found your what you think is hypervisor code, what you think is the handler, okay, well you go back into source point, you jump down to that space on the processor core of interest, the one that you actually set your breakpoint on, so it's currently executing, and search for it. Sure enough, I search and I look. Hey, it looks like my code. I find my VM read, and I find my resume. And so I set a breakpoint at the beginning of it because that's the whole point. With this hardware emulator, I should be able to break at the hypervisor. So once you set the breakpoint, start the thing back up again, and actually almost immediately it hits the breakpoint. Hey, it worked. It worked. I'm in the hypervisor. And so once you're there, you can step through and do all the regular debugging things. Yeah. So you can find out the guest EIP. Do all that sort of debugging fun. Of course, like I said, it's not, it doesn't solve everything. It's just a tool here. It gives you some neat capabilities. But one big limitation is you can't actually step across the ring -1, ring 0 boundary, which is what I was really hoping for because that'd make life great. Because it'd be nice if you were just stepping along and you hit the jump into hypervisor mode and exit and it would just step right in there. But no, it's not that nice. And so, because basically, like Jason said, when you're doing stepping, when you're setting breakpoints, it works a lot like a regular debugger, just with different instructions. But it still uses like the trap flag. And so when you jump into VMX mode, trap flag gets cleared, and you're hosed. So you still have to try to find the hypervisor. And so finding it, again, is tricky. You can get some idea of what code is triggering it, but you can't actually find it in memory in an easy way that, I've found yet. So basically, you resort to dumping memory. But the emulator is helpful for that. Slow, but it works. And then some newer VM instructions cause issues like AMD's, SK init instruction or Intel's, secure load instructions. Basically, they're meant to be part of a secure boot process. And one thing they happen to do is that when you go into into VMX mode and you're running one of these instructions, it disables hardware debugging, because in essence, all the hardware debugger is using JTAG. And so as soon as you go into this mode, it just turns off JTAG while you're in this secure initialization mode. And, well, that's not good either. So in summary.
Okay. Yeah, so in summary, you can see the power of, adding hardware and software. I mean, there's a lot of other macros that you can do when you encounter protections. But again, when you combine software and hardware, see its majesty, you'll wind up with a Debugginator. Again, just a reminder, we're on script, so we can't answer questions right now. Thank you for your time. Oh yes, and here's our contact information. If you do have questions, shoot us an email and we'll be happy to answer it. Okay, that's it.